Hi, this is Gerrits. Welcome to this lecture. In this lecture we're going to take a look at network economics, an important topic for doing business on the internet. We'll start by defining network economics and make sure that you understand what network economics are. After that, we're going to take a look at the rules of the game when network economics exists. People that have had a classic education in economics in many cases find it hard to understand what network economics really mean. This is due to the fact that when network economics are in play, the rules of the economy, the rules of what's valuable and what's not, are different than in traditional economics. In traditional economics, something is valuable when there's not a lot of it, so like gold or diamonds or oil. If there's not a lot of it, it's very valuable. When a product or service has network economics, it's the other way around. The more there is, the more valuable it is. Let me explain that to you. Services that have network economics are services that are being built up of multiple components. These components are complementary. This means that all components have to be available in order to deliver the value of the product or service. The simplest example of a service that has network economics is the phone service. You need two components, namely two phones, to get value out of that. Your phone only has value when there's another person that has a phone that you can call with your phone. Only when the two components, the phones in this case, are there, your phone has value for you. This is opposite to traditional economics. In traditional economics, something is valuable when it is scarce. So, looking from the perspective of traditional economics, when you are the person on the globe that has the only phone on the world, you would have something that would be very valuable. Now, in network economics, that isn't the case. If you would be the only person on the globe with a phone, it will be worth nothing. Even more, the more other persons have a phone, the more valuable it gets for you. Let's take as a starting point that there's one other phone in the globe that you could call. You would get a certain value out of that. However, when a third person with a phone would be added to the system, your value would double, because you could use the phone to reach twice the amount of people. Even more, the other persons can also reach twice the amount of people, so the value of the network would grow very fast. The more phones there are, the more valuable it gets. A lot of business models on the internet have network economics. One of the best known probably is Facebook. The service of Facebook is composed of two components, consisting of you and your friend. If you would be alone on Facebook, there would not be any value for you from Facebook. Only when those other components, in Facebook's case friends, are there, you will get value out of your component. The fact that the value that we can get from our components is dependent on external factors means that we often talk about network externalities. It indicates that we only can get value based on external factors. Network externalities can lead to a lock-in, meaning that the user of the service based on network economics can't go anywhere else anymore. Let me give you an example of that. If you have a profile on Facebook and your friends are on Facebook, both components to get value out of Facebook are there. Now say that a new networking site comes up and you think it's better than Facebook and you want to join that. You close down your account at Facebook and you move over to the new network. However, there's no value for you there because you're alone. Your friends are still on Facebook. Of course, you could ask them to join you in the new network too. However, they would only join if their friends would join. And their friends, of course, would only join when their friends would join. So in that way, we are stuck in Facebook. That's what we call a lock-in. We are locked in into the service. From a business perspective, this is good, of course, because it means that it's hard for your customers to leave your service. You've basically built barriers to exit for them. Network effects are being called direct network effects when the components can be associated with customers, like for example in a phone network or with Facebook. Adding one extra component delivers extra value for all participants in the network. Until now, we've talked about network components that are the same, like phones or Facebook friends. There are also network effects when components are different. Think, for example, about an online marketplace like eBay. On eBay, sellers and buyers exist. A successful transaction needs one of each of those components, a buyer and a seller. The same holds true, for example, for Uber, where the components are drivers and passengers, or for Airbnb, where the components are landlords and visitors. In order to create value in Uber, drivers should have passengers and passengers should have drivers. Only when these two parts come together, the value is being created. The network effects in these cases are called indirect network effects, because they're not related to the part that's being added to the network. If an extra buyer is added to a marketplace like eBay, the other buyers don't get value from that. On the contrary, more buyers on eBay could mean that there's more competition between the buyers, which will drive prices up for each of the buyers. So more buyers might mean worse prices. However, there's an indirect network effect. If there will be more buyers, the amount of sellers will increase because they will be attracted to the larger buyer base. So that's why we call this an indirect network effect. This brings us to the topic of one-way and two-way networks. If both components are the same, like in a phone network or on Facebook, it would typically be a two-way network. Both sides can communicate with the other side. When there's two different components, like a buyer and a seller on eBay, or a television transmitter and a television receiver, it will typically be a one-way network and a one-way network effect. The network effects are indirect. When there are network effects, so it means that the value that you get from your component depends on external factors, like the availability of other components, an interesting question comes up. How do you create network effects? How can you create adoption in the beginning? Who will buy the first phone and not be able to call anyone? When would you buy one? Because if you would be the first one, you would have not been able to call anyone. So probably you wait, and you wait, and you wait, until there are enough people having a phone. And then, not just people, but people that are in the group of people that you might want to call. So you wait. Then after some time, a lot of people have a phone. Basically, maybe almost everybody has a phone. If that's the case, it's a fairly simple decision for new joiners to buy a phone too. What we see in economies that have network economics is that they need to achieve scale. They need to get some kind of critical mass, and once they have that, when the network is big enough, it's a no-brainer for new joiners to join in, because the value is already there. If you buy a component, there are other components to get the value out of your component. So the question when you build a new business based on network economics is, how can I gain critical mass? How can I grow fast so everybody will want to join in? Imagine yourself being the best salesman of a telecom company in the 1990s. Your boss calls you in and he says, "Hey, listen, you are the best salesperson we have. Now we have this really new product. It's called a fax machine. You put some paper in it with writing, and it will pop out on the other machine on the other side so the receiver can read your handwriting. I've put you on the list to be the first salesperson in Europe to sell these. So please go ahead. This is very, very new. Everybody will want to buy it." And the boss sends you away. Of course, if you know something about network economics, you know that this will be a pretty hard sell, because who's going to buy the first fax machine? You need to achieve critical mass first, before it will run. How do we do that in business? Typically, we give it away to the first adopters of the technology. The organizers, so the sellers of the components, pay for the network to grow, to get enough scale so that it would be valuable for other persons to join in. You have to achieve critical mass in order to build a viable business model when your business has network economics. However, once you realize that critical mass, when you're big enough so that new customers are happy to join in, the fact that you have network economics will bring you a lot. That's because if you have lock-in and have a large network, you have a big chance of creating a monopoly. We already talked about it when we talked about Facebook and your friends not being able to go away because of lock-in. When you have a big scale, newcomers will join you and not the competition that's smaller. So it will lead to a monopoly. That's why VCs and other investors like companies that have network economics, because they know that once you've received critical mass, you can grow into a monopoly. And when you have a monopoly, you can make money. Let's go back to the question of building critical mass. In some cases, you can build critical mass faster by not building an entirely new network of components, but by using already available components. That's how the mobile phone was introduced. When the mobile phone was introduced, it was possible for callers to call landlines with their mobile phone. So one component was a mobile phone, while the other component was a traditional landline phone. In this way, even the first buyer of a mobile phone could get value of it by calling a landline. This is a strategy that we see a lot in industries that have network economics. Try to use existing networks to build scale fast. Of course, it means that the new technology should be compatible with the old technology, because only then you can make use of the old technology components. In industries that have network economics, we see a number of examples of good and bad compatibility. Let's take a look at some of those. Let's take a look at the television industry. The first televisions were black and white televisions. The signal that the antennas would send out and was received by the antennas was a black and white signal. In order to speed up the introduction of color TV, the color information was sent out as an extra signal next to the existing black and white signals. New color televisions were aware of the color signal and projected a color image on the screen. All black and white televisions didn't know about the extra signal. They just kept receiving the black and white signal and could use that to project a black and white image on the screen. That was a fairly simple rollout of a new technology using compatibility with the older devices. Only the transmitters were upgraded and the televisions did its magic automatically. This is, however, not always possible. To stick with TVs, we've seen some gone wrong with widescreen TV, then HD TV and now the newer versions of the TV. These aren't all successes, and that's due to the network effects in these cases. It has to do with the fact that you as a television buyer only get value of your component when the transmitters are delivering the same component too. Consumers don't buy a new television as long as there's not enough programs being broadcasted in the new technology. And broadcasters don't start broadcasting in the new technology as long as there are not enough TV receivers for the new technology. It's a chicken and egg problem. In order to solve this, both sides have to develop at the same time to make sure the new technology gets adopted. And this is challenging in many cases, because who would like to invest as the first party when the other party hasn't invested yet? It could mean that you buy a new TV with the newest technology, but you can't see any program in it because the broadcasters don't transmit any programs in the new technology. What we see in many cases is that a technology that has network economics can get stuck in the current technology, because the first buyers of the next generation technology do not get any value out of their investment in the new technology until the entire network has moved to the next generation technology. And that's because in a network, the quality of service is defined by the weakest link. No matter how good your component is, how much you have invested in your phone, if the phone of the other party is really bad quality, or if the network has some part that has really bad quality, the weakest link will define the quality of the connection. So it's very hard for people to invest when they don't believe that the rest of the network will also invest in their parts of the network. Government regulation can ensure that the entire network will be upgraded to the new technology, or that everybody has access to the new technology. Imagine, for example, that you are setting up a new mobile phone network with the best technology available. Where would you put your first antenna? Yes, of course. You will put that antenna in the most densely inhabited area of the country, because then you can reach as many potential customers as possible with a single antenna, so the cost per user can be low. The next antenna will be on the second most densely populated area, and the third antenna, of course, on the third most densely populated area of the country. When left to business economics, not all parts of the country would be covered with your network. You will not bring your network to that single person on the island up there 20 kilometers out of the country. it doesn't economically make sense to put up an antenna for just one person, so that one person will never get mobile phone access. That's why we need government regulation in these kinds of markets to make sure that everybody will have access to the new technology. This was, for example, the case in the 3G licenses and will be the case in the 4G or 5G licenses. The government will see that when you buy a license, you will have to cover the entire country. So to summarize, we've looked at network economics that have some specific rules of the game. In short, services consist of multiple components. The more other components there are, the more value for everyone. In order to be successful, critical mass has to be achieved. But once that has been achieved, there's a large chance of creating a monopoly. Scale can be created faster by making new components compatible with older components. However, this means that first buyers of the new component might not be able to gain additional value out of the new component, as the weakest link defines the quality. Therefore, the entire network has to be upgraded, which can be challenging. In some cases, only government regulation can assure that everybody has access to network services, as pure business economics would not enable access for everyone. This finalizes our discussion on network economics. Thanks for your attention. In case of questions, do not hesitate to reach out. Bye bye.